Let's keep this rolling here. My next guest is here backstage, and let's bring him on. We're talking to American Battery Technology, ticker ABML. There is the CFO, David Corsau. David, welcome to EVCon.
Oh, thank you. It's great to be here.
Do we have a presentation or a deck from you?
We do. Let me share my screen.
There we go.
Okay.
Floor is yours, sir.
Well, thank you, and it's great being back here with Benzinga. The first slide that everybody's seeing right now is just an architect's rendering of what our pilot plant facility will look like in Fernley, Nevada. And we have made all of the filings necessary, and that process seems to be coming along. It is a bit of a bureaucratic process, but one that we're familiar with. So we are in the resource recovery business, and so the first few slides here I'm going to talk about differentiation, and then I'll move into issues and opportunities and demand, and then kind of go to the points of pain and in our niche and how we propose to address those. So at this point, we are a leader in the critical material and lithium-ion battery recycling space. We do recycling. We have recycling technology. We have extraction technology, and that allows us to be a good steward for Earth resources, and I'll get into that in just a minute. There we go. Hide that. So this screen is about our differentiation primarily. So as all of you know, there's a huge growing market for battery recycling. 15 million tons of lithium-ion batteries in 4 years will be worth almost $1 billion. Our technology has been affirmed in multiple areas from global leaders as well as U.S. significant partners, and I'll talk about that.
Hey, David, can I jump in for a second? Can you just hit that use slideshow button on the top of the screen there?
Sure.
It'll make it much easier to read.
Yeah, okay, thanks.
There we go. Thank you.
Seems like every presentation I do, the forum and the portal is a little different, so apologies to everybody. So, okay, so award-winning processes, I'll talk about that in a minute, but our technology keeps being affirmed by the likes of DuPont, BASF, U.S. Department of Energy, and others. We hope that our technology is disruptive as we think. It's certainly clean, and again, it's been affirmed by the companies I just mentioned. One of the really cool things about what we're doing is we will have the first non-thermal lithium-ion battery recycling plant in the U.S., just outside of Fernley, Nevada again. Our annual capacity is 20,000 metric tons per annum of feedstock, so that is what we'll be able to process through our pilot plant. We got a great team. Many of the people on our tech team were responsible for building the Tesla Gigafactory and the R&D that went on at Tesla. Again, many of you who are following this market understand that the demand for EV cars, electric vehicle cars, and the associated batteries is going to be huge, especially in the next 9 years. You can see how it jumps from a very small portion of global electric vehicle sales to pretty substantial, and then by 2040 it becomes dominant. So the part of the point of pain here, and we all go through that as business leaders and analysts, problem solvers, is that only 1% of the global battery materials that you need, critical metals, to make EV batteries and consumer electronics for that matter, are produced in the United States. You can see where else they're produced. So by having a robust recycling program and presence in the United States, we can recycle many of these critical metals rather than shipping them back outside the United States and have them treated in various forms and then come back to the U.S. It shortens the supply chain dramatically. So this is, again, in brief form, this is the problem. So as you can see, majority of batteries in the U.S. that are, in parentheses, recycled are actually exported to Asia. The majority of those batteries are melted at 3,000 degrees Fahrenheit, and there's all kinds of problems with that, including pollutants, and then what you lose in terms of those critical metals. And so you've got a recovery percentage that's less than optimal. So the catch is every battery exported to China just exacerbates what we're trying to do in the U.S., even to the point of it maybe being a domestic supply chain and domestic protections for what we want to do in the U.S. Maybe it's a little bit analogous to when the petroleum reserve was created in the United States back in the late 40s, because the U.S. wanted to become petroleum independent. We look at our industry and the folks that are becoming prominent, not necessarily as competitors, but sometimes we try and learn from them. We think that there is a time when we may be doing business with many of these companies that you see represented, by their icons. So there is a differentiation here in how we all go about the resource recovery process. So as you can see, the predominant method in the world right now is this thermal process, where the batteries are smelted. They're melted at very, very high temperatures. And you can see along the bottom of the slide here, on top there, what's lost. It also is a polluting process. So more simply, if there is a hydro process, which involves solvents and waters, and it's in a separation process, you just recover less, and you spend a lot of money on really expensive solvents. So again, one of our differentiations is we have a 90+ recovery rate on when we look at our key metals: cobalt, nickel, lithium, and manganese primarily. Our process discharges very, very little pollutants. We do capture them because it's an automated process. Our recovery is high, and we don't use a thermal process. And it's very friendly in terms of getting the materials that are pollutants and then processing them. We can use our water over and over again. The other magic about our process is that the key metals, nickel, cobalt, lithium, and manganese, again, are almost infinitely recyclable. If you have the right process, you can use them over and over again, which has a huge economic benefit. So we've all heard about and talked about a closed loop economy. This is why that closed loop is actually open. There's not good end-of-life options right now. Probably at least 40% of the lithium-ion batteries in the United States that are thrown away, become waste, end up in waste management, all kinds of places like that, end up in a landfill. And so you have lower recovery, and then you still have a lot of pressure on mining to create and recover those virgin resources. So our difference is twofold, really. We have a really high-speed disassembly process. So again, our engineers, many of them worked where they were tasked with building EV batteries, so we understand how to take them apart, and we do that without a thermal process. It's very clean. We can quickly recycle tons of battery waste, consumer electronics, and end-of-life batteries, and then quickly get them back out into the marketplace. So we also have an effective management of electrolytes, dissolved species, water, and volatile vapors. Having been in the manufacturing business in several areas globally, our water treatment systems, the one that we will put in our pilot plant, is amazing. Works very well. So again, back to resource recovery. You can see the Tesla Gigafactory there in the screen, and our CEO and CTO Ryan Melser was a former engineer at Tesla, created their battery program, was involved in R&D, and is very well known in the industry. And so what he's created with his team is a very elegant recycling process that again can take feedstock, and we can run it through the recycling process and go from feedstock to refined critical metals in less than a day. So I mentioned earlier about how our technology has been affirmed, and so I'll give you a couple examples of that. So in late 2019, BASF, which is the largest chemical company in the world and also one of the larger cathode manufacturers in North America, decided they wanted to run a contest to see who had the largest clean technology for recycling lithium-ion batteries. Over 100 companies globally participated, and we were named the sole winner. So what that did is it helped us form a close relationship with BASF, and we work with them now daily on the refining of our metals, showing them what we can do, and we believe we've lined up a great customer for when we begin full production. This dual track just is the closed loop again, but what it talks about is the fact that our technology also lends itself to extraction of these primary metals. And so recently we won a grant. We were awarded a grant from the DOE and DuPont, where we're going to do a demonstration facility in western Nevada, extracting lithium from clay samples, and this is talks about that. So we gained DuPont as a partner. Again, this is a demonstration project that'll take 3 years, and it doesn't compete with our recycling process and goals at all. It just is a further demonstration of our technology and how in the U.S. we can actually extract lithium from claystone and brines. This is the executive team. Ryan again is the CEO, CTO, and it's a great team. All of us have a lot of mining, manufacturing, even software and logistics background. So what does all this mean? There's a huge growing market for battery recycling, as all of you know. Again, our technology has been affirmed in multiple ways by some global competitors. We can both recycle and do metal extraction from virgin resources. Again, the industry leaders, we think this gives us a real differentiation. Our pilot facility will begin construction, and when fully constructed and equipped with the capital equipment for processing, 20,000 metric tons per year of battery feedstock will be produced and be consumed and processed. Again, a really highly experienced team. So I ran through this rather quickly because I know, like the rest of you, it's easier to have a conversation rather than a presentation. So if everybody's good with this, maybe we can just move into the Q&A.
Thank you so much, David. Hey, we have time for just like one question. So let's see if we have one from the chat. I'll give deference to you because I feel like I ask too many of my own questions sometimes. So let me hop in here. Okay, David, let's go with this question. I see you're on the OTC QB, ABML. Give us an update. Plans to uplist. Timeline, anything on that front?
I believe it's public knowledge now. We have made an application to uplist to NASDAQ,
right?
And we're going through that process. We have filed and are awaiting response from NASDAQ. And as everybody knows, it's just a process, but we think we're in good shape, and we think that eventually that'll happen.
Yeah. Okay. So I guess there's no update. The answer is no update.
No, we're in the queue. We're in the process.
Fair enough. Okay. Wait. Let me just check here the chat. They're asking for an indication as to when construction can start. I don't know if you can speak to that.
Every indication is that we will be engaged in that. I can't exactly say when, because it's also a process that is within the city of Fernley. We have given them all the information they need, so we're just waiting. We're just waiting.
Have they given you any indication as to when they're going to even tell you, or no?
Well, back in July, we had a unanimous, this looks good, let's move to the next step. We've then made the required successive filings. We believe they have everything they need. So, this is a touchy thing, and that if you say, I think we'll have it pretty soon, and then it becomes extended, then I didn't tell you the right thing. But we believe it's all on a good track.
Okay. David Corssaut is the CFO of American American Battery Technology Corporation, ABML is the ticker. David, thanks so much for joining EVCon today.
Oh, it's great to be here. Thanks you again for hosting us.